Hi there, and welcome to this lesson. In this lesson, we'll be learning about the areas of plane shapes, okay, and we would be doing parallelograms and trapeziums. We learn to find the areas of parallelograms and trapeziums. Interesting. And as the lesson progresses, if you have any issues at all, anything comes of us unclear, please feel free to get in touch. Okay, we're always here, we're always happy to help. And also very important to set the video to play in 1080p HD, okay, so you can see everything clearly, and you can do so via the settings icon on the bottom right. Okay, so let's jump right into the lesson. Now, parallelograms and trapeziums. Now, what is a let's talk about parallelograms first. What is a parallelogram? Now, a parallelogram is a quadrilateral that consists of two sets of parallel sides. Okay, very simple. It's actually a skewed rectangle, and this is what it looks like. Okay, and to find the area of this shape, this parallelogram, actually very simple, very similar to finding the area of a rectangle. You simply multiply the length, the base length, okay, the horizontal length by the vertical perpendicular height. Okay, you do not multiply by the slant height. Okay, you need to be very careful about that. You multiply by the vertical height h, the perpendicular height h. So, and that is it for parallelogram. There really isn't much to it. Okay, you have the area as length times height. Okay, let's move on. Now let's talk about trapeziums. Now trapeziums are a lot more interesting. Okay, now trapezium is a quadrilateral that consists of one set of parallel sides, okay, and another set of uneven sides. Okay, and this is what trapeziums you can have. You can have trapeziums like this. So you have a set of parallel sides, so you can have like A and B, and then the other set of sides aren't parallel, and they could be anything, to be honest. You can have them the way you have in the first diagram, or you can have one as completely vertical and then the other one slanting. They pretty much come in different forms, and if you were to find the area of a trapezium, you would use this formula: a equals a plus b divided by 2 multiplied by h. Okay, what you notice is that the trapezium has uneven lengths on the parallel sides, so the lengths aren't equal. And what we pretty much do is we find the mean of this length. We'll find the average length. Okay, and we have a plus b divided by 2, and we'll multiply this average length by the height, and that gives you the area of a trapezium. Now, if we look at the second diagram, okay, the one with a perpendicular side and a slant, let's consider there's some things we need to take note of. Okay, now what you note is that the trapezium there is actually made up of a rectangle and a triangle. Okay, and sometimes you may not be provided with all of the information as you have been provided here. For example, they could take h out and give you the length of the slanting side instead. And to find h, because if you look at that shape there, what you have there is a triangle, and if you want to find h, you can actually apply pretty much every law regarding triangle. Sometimes you can do trigonometry, sometimes you can do Pythagoras' theorem. Okay, you're going to introduce this side, let's say the adjacent of that triangle there as an m, and m in this case would be b minus a. Okay, so you have b minus a, you'd have m, and then once you have m and you have l, using Pythagoras' theorem, you can find h as h equals the square root of l squared minus m squared from Pythagoras' theorem. And sometimes you may be given an angle theta, and then you can apply trigonometry. Let's say you're given a slant height and you're given an angle theta and you need to solve for h. you can actually get h as L sine theta. So these are some of the interesting things you can actually work with trapeziums. Basically, when you're asked to solve for the area of a trapezium, they may come in different forms. So it's very important that you take note of these things. Okay, so let's do a few examples. Okay, so I have example 1 here, and example 1 says find the area of the parallelogram below. Okay, so very simple parallelogram. We have the horizontal length as 15 cm, and we have the vertical height as 10 cm, and we go ahead and solve that quite simply. The first thing we need to do is identify the relevant formula. Very simple formula: A equals LH. Okay, identify our parameters. We have that L is 15 cm, i.e. the horizontal length, and H, the vertical height, is 10 cm. And I think we can go ahead and impute those into our formula, and what we have in the end is A equals 150 cm squared. Simple. There really isn't much to it. All these stuff are actually really easy. Let's do another example. Now example 2. And example 2 says find the area of the trapezium below. Okay, now we're dealing with a trapezium, and just like we did for example 1, the first thing we want to do is we want to identify a relevant formula, and the formula for finding the area of a trapezium, quite simply, is you find the mean of the two parallel sides, okay, and you multiply by the vertical height. And we've been given the two parallel sides. In this case, we've been given the parallel sides as A equals 5 cm and B equals 10 cm, okay, and our vertical height, perpendicular height, is 4 cm. And I believe we can go ahead and put those into our formula, and what we have in the end is we have A equals 5 plus 10, okay, divided by 2 times 4. A equals 15 divided by 2 times 4. A is 7.5. 15 divided by 2 is 7.5. And then you have that your A is 30 centimeters squared. Simple. Okay, so I think we can move on to example 3. Okay, so example 3, and example 3, now this one looks interesting. Now example 3 says find the area of the trapezium below. Now we've been given the two parallel sides, the length of the two parallel sides, and we've been given a slant height as well. So how do we approach this? Now to solve this, something we need to do, something very important we need to do, we need to get the perpendicular vertical height. Okay, the vertical height, very important, because you can't work with the slant height. Okay, because the formula says A plus B divided by 2 times H, i.e. you can't work with the slant height, so you actually need to get this perpendicular height in. Okay, so H. Now, and to solve for H, I think we can work with Pythagoras' theorem here. I'm going to introduce M over there. Okay, and once we have these, I can go ahead and say my M equals 13 minus 7. Okay, the length M, that's the A adjacent of the small triangle there, is the length 13 minus the length 7, and gives me 6 centimeters. And then I can go ahead and say from Pythagoras' theorem that my H equals the square root of 10 squared minus 6 squared. Okay, and what I have in the end, I think that's 100 minus 36, 64, square root of 64, and I think I'd have the H equals 8 centimeters. Okay, now that we have H, we can now go ahead and work with our formula. We have that A equals A plus B. The area is A plus B divided by 2 times H. Okay, and I can identify my parameters as A equals 7 cm, B is 13 cm, and H as 8 cm, and just go right ahead and put all of that into my formula. And I have that the area of the trapezium there is 7 plus 13 divided by 2 multiplied by 8. You have 7 plus 13 as 20. When you divide that by 2, you have 10 times 8, and what you have in the end is 80 cm squared as your area of the trapezium there. So very interesting trapeziums. To be honest, they can come in different forms. Okay, they can have angles. You can have, sometimes they could even take out B. Okay, and basically they give you maybe an angle and M, and you solve for M, and then you have B, and it can come in different forms. But once you understand that this trapezium is actually made up of a rectangle and a triangle, and you just need to know how to manipulate whatever information you're given to get what you ought to be working with, i.e. A, B, and H, you're pretty much good to go. Okay, so that would bring us to the end of this lesson. Okay, it's a very simple lesson. There really hasn't been much to it, but yeah, bye for now.